Have you ever wondered how neural networks are similar to our brains and yet so enigmatic? Well, let's unravel this mystery together. Neural networks, these fascinating constructs of data science, are like digital mirrors of our brains. Just as our brains learn from experiences, neural networks learn from input data. They sift through this data, identify patterns, and make accurate predictions. These systems are complex, intricate, and multi-layered, just like the human brain. They can process vast amounts of information, decode it, and output something meaningful. However, as with any complex system, there is a specific way to approach them. Just as you wouldn't start a philosophical debate with a 5-year-old, you don't want to bombard your neural network with inappropriate queries. So, the question arises, how do we navigate this labyrinth of interconnected nodes and layers? What are the golden rules to query these intricate systems accurately? Let's dive into them. No matter how complex a neural network is, there are some rules of thumb that can help us get the most out of them. First, always ensure data quality and relevance. Remember, garbage in, garbage out. You can have the most sophisticated neural network, but if you're feeding it irrelevant or poor quality data, the results will be less than stellar. The second rule is understanding the architecture of your neural network. Just as you wouldn't try to navigate a maze without a map, you shouldn't query a neural network without understanding its structure. Knowing the layers, nodes, and connections will help you understand how your network processes and learns from data. Thirdly, know your problem. Neural networks are versatile, but they're not one-size-fits-all. Different problems require different types of networks. For instance, a convolutional neural network is excellent for image recognition, but may not be the best choice for time series forecasting. The fourth rule is to avoid overfitting. Overfitting happens when your network learns the training data too well. It fails to generalize to new data. This can be avoided by using just the right amount of data and employing techniques such as cross-validation. Lastly, always test and validate your network. Regular testing and validation can help you catch errors early, adjust your model, and ensure that it's performing optimally. Mastering these rules will put you on the right path, but we're just halfway there. Are you ready for more? Let's continue our journey through the maze of neural networks. Rule 6. Choose your activation functions wisely. They can make or break your network's learning process. Think of them as the gatekeepers of your neural network. Rule 7. A little tweak can go a long way. Adjust your learning rates optimally. It's a bit like Goldilocks, not too hot, not too cold, but just right. Overdo it, and you might overshoot the optimal point. Underdo it, and you might be stuck forever in a local minimum. Eighth rule, a hint from the mathematicians. Leverage regularization techniques. They're your best bet against overfitting and ensure your model generalizes well. Rule 9, understand the importance of batch sizes. Like a well-balanced meal, the right batch size can fuel your network's learning effectively. And finally, Rule 10, keep up with the latest research and advancements. Remember, in the world of neural networks, the only constant is change. With these 10 rules in your toolkit, you're ready to conquer any neural network. Navigating the world of neural networks can be a daunting task, but not when you're armed with the right rules. From understanding the architecture to knowing when to use a bias node, every rule we've discussed plays a pivotal role in querying neural networks effectively. These rules are not just guidelines, but vital tools in the hands of any data enthusiast. Remember, understanding is the key, and with these rules, you're well on your way to becoming a neural network mastermind. Happy querying!